Hello 6303. In this video, I'm going to introduce you to quantitative research. Keep in mind, this is just an introduction, and you're not going to walk away from this video with an in-depth understanding of how to conduct quantitative research. That skill is going to take time and practice to develop. Instead, I want you to focus on getting familiar with quantitative terminology and general design elements of quantitative research. Many textbooks are written from the assumption that you already know the difference between quantitative and qualitative research. However, based on my own experiences as a student and on previous teaching experiences, I know that it's going to be beneficial for you to master the terminology before you begin reading and writing about quantitative research, and definitely before you begin designing your own quantitative research. So for this video, we're going to focus on accomplishing the following objectives. Number one, I want you to be able to define quantitative research in general terms. Number two, I want you to be able to identify the independent, dependent, and control variables in a study, as well as possibly identify the confounding variables. Number three, I want you to describe the difference between the different types of quantitative design, including action research, quasi-experimental, pre-experimental, experimental, and correlational research. And number four, I want you to be able to identify samples and populations in a study. Let's start with a general definition of quantitative research. Quantitative research can be defined as observing patterns in numbers and making those observations through statistical procedures. Quantitative research is deductive in nature and uses existing theory to test a hypothesis. One of the most important terms to understand in quantitative research is variable. A variable can be defined as anything that has a quality or quantity that can change. That generic definition is broken into three main types. The independent variable, which is the one the researcher chooses to manipulate or change on purpose. I always remember it like independent I. I am the researcher, and I choose to change so-and-so. The dependent variable is the change the researcher wants to measure. The independent variable is believed to have an effect on the dependent variable. So I have the power to manipulate the independent variable, and that measure will depend on what I chose to change. Controlled variables are qualities or quantities the researcher tries to keep the same. Confounding variables are outside influences the researcher either failed to account for or couldn't control. Confounding variables change the effect of an independent variable on a dependent variable, and they can ruin your results. Confounding variables will become very important when you are trying to generalize results to other populations. Are you feeling a bit lost? That's okay. The terminology can get quite confusing if you haven't ever used it before. So let's try a little bit of application. I'm going to give you a few scenarios, and I want you to determine what the independent and dependent variables are. But first, we'll do some together. Let's start with something simple, sort of a throwback to your high school biology days. I just started a vegetable garden, and I notice that my plants aren't looking so hot. I'm thinking it might be because they're not getting enough water, but maybe they need some fertilizer too. I just know that I really want some nice plump tomatoes this summer. So I'm going to do a study on my plants and see if adding water and or fertilizer helps them grow better. So let's think about myself as the researcher. What variable am I choosing to change? AKA, what treatments or interventions am I going to use? That's my independent variable. What am I going to use to measure that change? This could be a scale, a quantity, or a quality. That's going to be my dependent variable. And then I have to figure out what I can keep the same. What can I control so that outside forces don't affect the results? To figure out the variables, you have to do a little bit of inferencing. I'm going to manipulate how much water and how much fertilizer the plants get. So these will become my independent variables. I want to measure how many tomatoes the plants produce. So that's going to be my dependent variable. I could even have more than one dependent variable, like the height of the plant, the color of the plant, how many leaves each plant has, and even the size of the tomatoes that it produces. All of those are what I can measure from the changes that I implement. So they are dependent variables. My controls are going to be things like the amount of sunlight they get, the type of soil that they're planted in, the date that all of my plants are planted, and wind exposure, since I'm going to keep my plants on the same part of the yard. Confounding variables that I might forget to account for when I'm designing this experiment, or that maybe I try to account for but they're out of my control due to forces of nature, could be things like my ducks eating the plants in one of the raised beds, or an infestation of bugs on one of the plants. That's your typical scientific experiment, but we're working with the social sciences, so we're going to take those same concepts and try to apply them to a social science scenario. So let's pretend that I'm a principal at an elementary school in the Texas Panhandle. My district recently purchased leveled readers so my teachers can implement Fountas and Pinnell, or F&P, guided reading. I know there is a lot of research behind this program, but I'm hearing a lot of complaints from my teachers about implementing it. So I want to determine if this program is effective. Are we seeing any improvement in our students' reading levels? Based on the scenario I just described, what do you think the independent variable would be? What is the intervention or the treatment? What would the dependent variable be? What would you use to measure the effectiveness of applying that treatment? What's your control? What do you have the ability to keep the same? And finally, what do you think the confounding variables are? What variables are outside of your control or might have an impact on your results? The intervention has already been chosen by the district. It's the Fountas and Pinnell's guided reading program. So that's my independent variable. That's what we have the power to manipulate. Now I need some ways to measure the effectiveness of the program. Since the program aims to improve students' reading abilities, I need something that's going to measure that. If you're familiar with F&P, you'll know they have suggested levels for each grade level. I could use that as one of my dependent variables. I could also use something like iStation, which is a computer program for reading. I could use standardized test scores. I could use a reading inventory or a whole host of other assessments. All of those would be my dependent variables because that's what I'm going to measure. Now my control variables get a little bit trickier in this situation. There are a lot of things that are going to be outside of my control in this scenario, but I might be able to control the class size of the students participating in this study, the number of years of experience the teacher has, and the number of minutes the teacher uses the program throughout the school year or throughout the unit that we're testing on. I'm not going to be able to control the students' previous experiences with learning how to read, or whether or not their parents work with them on reading at home. Those could be confounding variables. Okay, now it's your turn. For the next two scenarios, see if you can identify the independent, dependent, control, and confounding variables. I'm a school counselor at a rural school in Texas, and I have a lot of first-generation students who are unfamiliar with the college process. Their parents are also unfamiliar with how to select a post-secondary program. I'm going to provide guidance lessons to the juniors and seniors on college programs and how to choose a college. I want to know, though, if my lessons are effective or not. What is my independent variable? What is my dependent variable? what is my control, and what are the outside influences that might affect my results? What are my confounding variables? Give yourself a second and see if you can answer those. Let's try another scenario. I'm an instructor at a community college, and I'm teaching online courses. I've taught the same course for the past 2 semesters, and I notice my students are not picking up on the content that I want them to know. In the past, I've used things like PowerPoints, lecture notes, quizzes, and tests. But I want to see if adding videos to my online course will help my students learn the content better. I also want to see if adding those videos will help the students feel more connected to their learning. Based on this scenario, what is the independent variable? What is the dependent variable? What are the variables that you can control? And what are the variables outside of your control that might influence the results? Know those types of variables and know them well, because later you're going to have to apply them to articles that you choose to read for your own research question. For now, we're going to move on to Objective 3, which is describing the difference between quantitative designs. Action research, experimental research, quasi-experimental, pre-experimental, and correlational will all be discussed in this section of the video. Hopefully, you now have a strong understanding of what independent, dependent, and control variables are, and you have an understanding of how confounding variables can influence the results. So let's take that understanding and move into these different designs. We're going to start with true experimental design first. Creswell states this is a traditional design that involves random assignment of participants in at least 2 groups. At least one of the groups receives the treatment or intervention, and the other one does not. A subcategory of experimental design is the pre-test, post-test control group design. This is going to involve 2 groups. Both get the pretest. One of the groups is going to get the treatment. The other group does not receive the treatment. That's your control group. When the treatment is finished, both of the groups are also going to receive a post-test to measure if any change occurred. That's your dependent variable. The next type of experimental design we're going to discuss is a post-test only control group design. The reason you might want to use this design is because you think that if participants even see the pretest or the survey that you're going to give them in the beginning, it will influence the post-test or the results at the end of the treatment. So you're going to randomly assign participants into groups. A treatment is given only to the experimental group, but both groups are going to be measured on the post-test. So in this design, we still have 2 groups. We still have random assignment, but both groups are going to get the post-test as opposed to a pre-test and a post-test. The final type of experimental design we're going to talk about today is called the Solomon 4 group design. It's a special case of a 2x2 factorial design. This is also going to involve random assignment of participants to 4 groups. Pretest and treatments are varied for the 4 groups, but all of the groups are going to get the post-test. This is going to help eliminate the testing effect, where just taking the pretest can have an impact on those post-test scores, just like we talked about with the previous one. Let's apply one of these designs to one of the scenarios we just discussed earlier in the video. We're going to work with the instructor who wants to add videos to his online course. So we're going to have 4 groups, A, B, C, and D. Group A will randomly be assigned and is going to receive a content test and a survey prior to watching any course videos. They'll watch a course video for each module in the class, and then this group is going to take a content test and a survey after the intervention has concluded. Group B is going to also be randomly assigned, and they will take a content test and a survey, but they're not going to get any videos for their course. It's going to be the traditional design. This group will take a content test and a survey after the intervention when the other groups have concluded. Group C will also be randomly assigned. They're not going to take a content test and a survey prior to watching any videos. They will get the same treatment as Group A. They get to watch a course video after each module in their course. And they will take the content test and survey after the intervention for the other groups has concluded. Group D, also going to be randomly assigned. They're not going to take a content test and a survey prior to starting the course. And they are not going to get the treatment. They don't get to watch any videos. This group will take a content test and a survey after the intervention has concluded. So if you look at this chart, you can see how those four groups in the Solomon 4 design would be set up. Now keep in mind that if we want to be ethical researchers, when this study is finished, we need to offer that treatment to the participants who didn't receive it. So we would make those videos available to the students who didn't get to watch them in the first place. While the Solomon 4 will help eliminate the testing effect, it's not going to be feasible for the principal examining the effectiveness of the Fontes and Pinnell reading program. The reason is because a teacher isn't going to be able to leave a group out of the pretest, that reading level assessment, because that's the foundation for the whole program. So here are what the other two designs would look like with the same scenario that we discussed with the online videos. In most real-life scenarios, true experimental design is very difficult to achieve, especially when we are working in education settings. Therefore, researchers may utilize other research designs that are pre-experimental and quasi-experimental. Pre-experimental does not have random assignment. The four types of pre-experimental look like this. Let's plug one of our scenarios into one of those designs. For the principal looking at the reading program, he might use the one group pre-test, post-test design. He would choose a first grade class, have the teacher give the reading level assessment prior to meeting in guided reading groups, have the teacher meet 2 times a week for 2 weeks, then have the teacher assess the students' reading levels again to determine if there were any growth. Quasi-experimental designs also do not have random assignment. There are 2 groups. One is experimental and they get the treatment. The other group is a control group that does not get the treatment. Here is a chart that explains the 3 types of quasi-experimental designs. Action research is a process in which participants examine their own educational practice systematically and carefully using the techniques of research. Because action research is typically conducted on existing groups, such as classes, true experimental design can rarely be achieved. Therefore, action research is typically pre-experimental or quasi-experimental. Many teachers conduct action research. Correlational design is where researchers use correlational statistics to describe and measure the relationship, degree or association, between 2 or more variables or sets of scores. Due to time constraints in this course, we will not be going in depth with correlational design. We do, however, want you to remember this phrase. Correlation is not causation. So this brings us to our 4th objective. Identify samples and populations in a study. We're going to talk about the difference between a sample and a population. The population is the set of entities under study. It's represented by a capital N. Most of the time, it is impossible to measure the entire population, so we measure a sample, represented by a lowercase n. We want the sample to be as representative of the population as possible, so we should choose a sample with similar characteristics as our population. For our scenarios, the samples and populations might look like this. There are many ways to select your sample, and you can read about sampling techniques by visiting this website, which I've also linked in the Module 1 folder. I would recommend looking over those and becoming familiar with them. That concludes the new content for our video. See if you can define quantitative research in general terms, identify independent, dependent, and control variables in a study, describe the difference between quantitative designs such as action, experimental, quasi-experimental, pre-experimental, and correlational, and identify samples and populations in a study. We realize that this video contains a lot of new content, so we recommend printing off the manuscript for reference later. You can find that manuscript in the directions for the Module 1 folder. We also recommend studying the Quizlet terms, which are hyperlinked in the Module 1 directions. Remember to use Blackboard course messages to email us with any questions. We'll see you in the next video.